All right, hi everybody. Welcome to lecture 3. We're going to be talking about relational databases for today. Just a few quick announcements before we get into the content of today's lecture. Your second assignment, PA2, is due this Wednesday, October 5th. All office hours are on the ed or that can be found on the syllabus page in the textbook if you need help for your assignments. And grades were released for PA1 this morning, so you can check CMS to see where you went wrong on the first assignment and get the relevant feedback. If you have any issues with your grader, if you have any issues with your grading, you can reach out to the person that graded your assignment, which is found at the top of your feedback file. So let's dive in to review. We're going to have a quick refresher for the content we've done thus far. So we've first touched the client-server model, in which we have the client, which is the device that the user is using, that be the phone, tablet, etc. That client then gives a request to the server. Then a route is triggered, aka a endpoint is hit. There's some form of data operation, that being some calculation of some form, that may be a CRUD operation. That being some CRUD operation, create, retrieve, update, delete. And then we have, so we have our data operation, that could be a CRUD operation. Then we have the server is then going to operate with our database. We touched on last week that could be an SQL command into our database. That data is then retrieved and given back to the server. And then we have our return response, in which the data that was fetched from the database goes to the server then gives our response back to the client. So here's a high-level overview of what's going on. So we have a request to the server SQL command to the database, get our database back to the server, and then we have our response from the server to the client. So we're then going to touch on a single table database, in which there's a structure into rows and columns. We talked about last week in how the column represents the type of the field, and then the rows is going to represent a single entry into our database. And we query and manipulate data using our SQL commands. So we have columns with the type, rows representing one entry, and then SQL queries to manipulate that data. So then this is a course overview of the topics we've done thus far. So we started on routes, our client-server model. We touched on basic databases. And now, it being week 3, we're going to touch on relational databases. So I just gave a high-level summary of all that we've covered thus far. Does anybody have any questions before we move on to our topic, relational databases? Okay, so moving on. Relational databases. So relational databases allow relationships between data. So touching on PA1, we have several comments for one post. But how do we know which comments belong to which post? Relating those two units of information. We have, moving on to like users and friends. Several users could have many friends, and then of those friends, they could also have different users being their friends. So how do we know which users? Okay, yes. So one user can have many friends, and then of those friends, they can also have many friends. So many to many. And then touching on PA2, we have which transactions relate to which senders and receivers. So we have many senders, many receivers, and then how do we relate those transactions between those senders and receivers? And then looking at this example here, we have our users table and we have our posts table. So we have their ID and the name in our users table. So Jessica ID 1, Shingo ID 2, and then we have our post table where we have an ID for that text post, the text itself, and then the user ID. So for an example, the user ID 2, if we go to our users table, we can see that that is related to Shingo, who has the ID 2. So Shingo, the user ID, has the text post, Shohei Ohtani is the coolest person ever. He loves baseball. So then relating that back to our users table, that is the user having the ID of 2. That's Shingo. So that user ID in our example here, this is called a foreign key. So our foreign key is a column in one table that uniquely identifies a specific row. It's also called a secondary key. So for example, in this table, the primary key would be the ID, the original ID, to uniquely identify each entry into this table, their post table. And then the foreign key would be also called the secondary key. So relates to our relates to our users table. So to summarize, our foreign key is a way to represent a relationship between two separate tables.
Oh, sorry.
So there are three types of relationships. There's one-to-one, one-to-many, and many-to-many. The way I like to think about it, it's similar to the different kinds of functions. So like, remember in like high school, you learn about like a one-to-many function, a many-to-many function, and a one-to-one, one-to-many, and a many-to-many, those kind of functions. It's the same kind of relationship. Sorry, we have a question.
In the previous example, what was the foreign key? Did that be user ID?
Yes, so in this example, the foreign key is the user ID. This foreign key creates a relationship between the two tables in which this entry has an ID of 1, but which user created it? How do we know which user created it? We look into our user ID column. The user that created it has the ID of 2. We then go to our user table. Which user has an ID of 2? That's Shungo. So we know that Shungo is the user that made this post. Does that make sense? Does everybody follow? Any other clarification? Okay, awesome. So moving into the types of relationships, the first one being a one-to-one. Essentially, one entry in one table, one row, relates only to one other row in another table. So one row in one table relates to one row in another table, and vice versa. So a good example of this would be students and net IDs. Every student has only one net ID. You can't change your IDs. You can't have multiple net IDs. Every student has only one net ID. And then vice versa, every single net ID only corresponds to one singular student, meaning that one net ID can't belong to two different students. So it's a one-to-one relationship, no sharing, essentially. So then using this example, we have our users table and our net ID table. So again, we have the user table with the ID of 10 belonging to Shungo, the ID of 20 belonging to Jessica, right? Then looking at our net ID table, the ID of 30 belong to the net ID of Jessica, of JZS27, right? And then looking at our user ID column, aka our foreign key, this net ID belongs to the user of 20. Then we go back to our user table. Which user has the net ID of 20? Oh, which user has a net ID of 20? Jessica. So again, using the other example, we see that the ID of 10 is Shungo. And then looking at our net ID table, we have the user ID of 10. This is Shungo's net ID. Does everybody follow? Okay, awesome. So again, other example, user ID 20, Jessica, user ID 20, JZS27. This net ID belongs to Jessica. Any questions? Yes?
Let's say like each user has one, like we already established that each user has one that can be associated, and that's like the only thing that's possible. So like what is, I guess like my question is like what is the benefit of like having two tables with like two different IDs for each object? Like so users, they have their own user ID, they have their like own net ID. Why not like put net ID and net ID like, into the user table as like fields?
Oh, great question. And we'll get into that later on the lecture. That's a great question that I want to think about, and we'll cover that in the different like later on in lecture. Essentially, that question will be addressed essentially. Great. Okay. So then here we have some SQL syntax. So that in the first one we have create table user. This should be familiar from last week when we dealt with databases. So the table is called user, and then they have the entries ID, that's the primary key, and then the name, text not null. Moving on to our second table, we have a second table called net ID. We have the primary key for that being the ID, the column called text not null, the net ID, and then here's our foreign key, user ID. So user ID, it's also an integer and it's unique, meaning this represents a one-to-one relationship, meaning that no two net IDs can have the same user ID, meaning that no two users, or aka students, can have the same net ID, no two net IDs can have the same student, essentially. And then to represent this, we have our foreign key user ID. And then this references, so foreign key and references are SQL syntax keywords. And then we have the table user and ID. So going over this again, this is our foreign key. So it's user ID, integer unique. It's a one-to-one relationship. We're then saying that this is a foreign key. The user ID column is a foreign key. And this foreign key references the table users. And then in that users, it references the column ID. So it's saying that the user, basically it's saying that the user ID in this table translates to the ID column in our users table. So the two are connected and it forms that kind of connection. So then again, using an example, we can insert into our users table the name with the value Jessica. So we're inserting into our table Jessica. And then we're inserting into our table net ID, the net ID, user ID, the values JZS27 and 1. So since this is our first entry into our users table, it's going to have the ID of 1. And we're saying that we're giving the net ID, this value in the net ID table, the value JZS27 and the user ID of 1, which we just established corresponds to the user Jessica. Does anybody have any questions? Okay, awesome. We're then going to move on to our second type of relationship called a one-to-many relationship. So one row in one table can refer to several rows in another table. A good example of this is baseball teams and players. So one team can have many players. And then again, and then those many players belong to one singular team. But then each player belongs to one team. So it's one team, many players. Those many players belong to one singular team. So it's one to many. So we're going to use a different example with albums and songs. So again, one album can have several songs, and those several songs belong to one album. So we have the album Igor by Tyler, the Creator. And then in our song table,
Sorry about that.
it's okay. In our songs table, we have the song Earthquake and the song I Think. Both of these songs belong to this should be album. Both of these songs belong to the album Igor. And then we have our second album for 444. And then those songs these songs over here belong to the album with the ID of 20. And then we check our album table, the ID of 20 has the album 444. And sorry, it's a little confusing with the incorrect table names. Does anybody have any questions? Essentially, multiple entries of songs belong to one singular album. So it's these two songs belong to the same album. These two songs belong to the same album. And then these two albums have multiple songs. Does that make sense? Okay, awesome. So again, some more SQL syntax. We have our album table, and then we have our songs table. So it's very similar. We have our ID, name, album ID. Then notice here, we do not have our unique keyword, meaning that several songs can share the same album ID. So that's where the one-to-many relationship comes in. And then again, we have our foreign key relating these two columns. The foreign key, album ID. This column, album ID, references the table album, and then within that table, it references the item ID. So we covered a lot. Does anybody have any clarifying questions or anything they want me to go over? Okay, awesome. So again, more SQL syntax. We're inserting into the table song, the name of the song and the album ID. So we're saying that we're entering the song Earthquake and the album it belongs to is 10. And then we can also do a query. We're selecting all from the songs table where the album ID is 20, where the album ID is 10. So essentially what this means is that from our songs table, we're selecting all of the entries that belong to the album with an ID of 10. Everybody got that? Okay. So then we're going to cover our last relationship. It's called many-to-many. So many rows in one table then references many rows in another table and vice versa. A good example of this would be students and classes. So many students are in several classes, and those different classes have many students. So for example, right now I'm in Algo, I'm in Psych, I'm in Spanish, so I'm one student, I'm in many classes. And then those many classes, so for example, Algo, that's a core CS class. That one class, again, has many students. It has 200 students. So we have me, one person having many classes, and then another one class having many students. You raised your hand?
Yeah,
Yes?
so, but when you name tables, is it convention to make it like singular? Like instead of naming it user, just call it user?
Yeah. Yeah. Great. So question was the naming syntax. If it's like a users table, it's like you name it user, but that's kind of like nitty gritty. So again, moving on. So the way to implement this, and Oscar kind of asked us earlier, why did we have that set up the example as we did earlier? We're going to touch on 3 different ways to set up a many-to-many relationship. The first 2 are not that ideal. And then the second one, the last one is optimal. So the first one, we're using multiple columns to store more foreign keys. So this was the example that Oscar asked about. So we have multiple columns to store many foreign keys. So here we have our net ID, and then we're trying to show the different classes that students are in. So Shingo is in CS 1110, 1998, and 2110. And then I'm also in 1110, I'm in 2110 and 2800. So here we have each foreign key is its own individual entry into the users table. And this is an okay implementation if we're assuming that all students are only in 3 classes. But what happens if a student wants to take more than 3 courses? Like what if someone wants to overload one semester because they need to graduate early and they're gonna have more than 3 courses? So for example, Gonzalo, he's in 5 courses this semester. And so we need more columns to account for these different foreign keys, more columns to account for more foreign keys. So what happens to these empty slots for Shungo and Jessica? We could make them be null, but this is not the best use of space, because what happens if we have someone, Rahi, he's only in 1 course this semester, super light, very chill, but we have all this wasted space if we have 1 column for each foreign key. So this could work, but it's not the best implementation of relating students to their courses. We'll now touch on a different implementation of relating users to courses. We now have a list of IDs. So in this example, we have Shungo, the list of courses are 1110 and 1998. These are the IDs of courses that he's in. And then if we go to our courses table, those IDs then relate to CS 1110 and CS 1998. But what happens if we want to add a user, add another student to one of these courses? Oh, and here's another example. So we want all the students that are in CS 1110. We then relate that back to our students table. It's 1 and 2. So we then go to our students table, given the IDs 1 and 2. So again, what happens if we want to add a student to one of these courses? So Gonzalo, he wants to be added to these courses. We then have to update the we then have to update this field in our courses table each time we want to add a student, so which is not the most efficient. So we add 1 student to these separate courses. We need to add his ID to these courses. So again, not the most time efficient. And another thing to consider is what happens to super big courses like 1110. There are like 400 students, meaning that this would be a list of 400 separate net IDs. Say we want to find like the net ID of like, say, 100. So we'd have to parse through 100 net IDs to get to like the 100th net ID, which again is not the most time efficient. So working with a list of IDs is not the best use of time, because like when the list of students in one course or gets really, really large, it's really hard to deal with. So then what's solution to this? We have our courses IDs and we have our students IDs. The solution is essentially to mash them together into something that we call a joined or association table. Here we have the ID and then the net ID. And then we have the ID and the title of the course, right? So the way to relate these two, we're saying that the student of ID 1 is enrolled in the course of 1110. The student of ID 1 is also enrolled in the course of 1998. the student of ID 2 is also enrolled in the course with the ID of 1110. So essentially, these are student IDs, and this forms a relationship with the course ID. So it's 3 separate tables, and one of the tables just relates the 2 tables. So again, this is the example I just walked through. Student ID 1 is that represents this relationship. And then say we want to see and that brings it over to the IDs with 1110 and 1998. And say we want to see all the students that are enrolled in the class CS 1110, we would look with the ID 1110, we would go to our joint association table, we would see all the course ID with 1110, 1110, 1110. Those are related to the students with ID 1 and the students with the ID 2. And then we go over to our students table. The student with ID 1 is Shingo. The student with ID 2, the student with ID 2 is Jessica. So essentially, that's how we relate the 2 separate tables. And then if we have someone, say I'm a student with ID 2, JZS 2 subject. Say I then want to enroll into CS 1998. It doesn't take much work. All it takes is just adding one more entry into our joint association table. Now a relationship between the student with ID 2 and the course with ID 1998. Now it's saying that I, Jessica, am enrolled in the course CS 1998. So adding or finding relationships is much more space and time efficient with a joint association table. So then just looking at this with some SQL syntax, it's saying that the student this is the basic tables we set up before. So we have our student and we have our courses, each with their own separate IDs, the primary keys. So the student has their net ID and the course has its title. We then have one more table, and that table is called the join table. The join table has its own ID. It has its own entry. It has its own columns for the course ID and the student ID. And then it also has 2 foreign keys. It's saying that the foreign key with course ID references the table, and within that table, which item, the ID. And then the foreign key student ID, it references the ID within the student table. So essentially, this line of code right here is related to this course ID, and this line of code right here is related to the student ID. So it's essentially saying that this course ID references the ID in the course table. This student ID references the ID in the student table. And now we'll move on to Shungo for demo. Oh, yeah, does anybody have any questions? I know I just covered a lot of content in about 25 minutes. Covered a lot. So does anybody have any last questions or anything else they want me to go over? Yes.
Could you go back like 2 slides to the other one? So
No.
On your example, like of the SQL code,
Mhm.
there's like another ID column. Do you need the other ID column then to auto increment?
Oh yeah. So
Is that missing that?
this is like a very high level, very simple, like bare bones structure. But that's a great question. In this case, this is each item in the join table will have its own ID. So if you want to pretend, there'd be another column right here called ID. So this would be ID for a join table, would be ID 1, 2, 3, 4. Does that make sense? So yeah, the join table is its own like structured table. It just wasn't included for this like bare bones representation, but great question. Does anybody have any other questions? Okay, awesome. On to Shingo.
Okay, all right. So like last week, we're gonna get started with SQLite 3. Let me play this real quick. On how we represent relations, right, within databases. So again, the 3 types of relationships that exist within databases are one-to-one, one-to-many, and many-to-many. So let's boot up SQLite 3, just like we did last week. And now we're in the SQLite 3 shell. Cool. So again, the way to create a one-to-one relationship is to create 2 different tables that have, one-to-one relationships, right? So the first one we're going to make, and you don't have to copy this. This is like a SQL demonstration on like how you're going to be representing these kind of relationships. But yeah, the first one is going to be a user table, right? It's going to have an ID, which is an integer. primary key, auto increment. Name is text, not null. And I see a few people copying, so I'm gonna let y'all do that, but you don't have to copy. You're not gonna be using this for your assignment. It's just for demonstration purposes. So that is the first table we're gonna make. The second one is the second table that is gonna have a one-to-one relationship with users with, right? The second one, let's create table, let's call it profile, which is gonna have also an ID. It's gonna have a net ID, right? So this is the example given in lecture. And then it's going to have a user ID. So note this unique keyword. We didn't have this in the one-to-many relationship. But the reason why we have a unique keyword is because each profile can only be ever associated to one user, right? So we want this user ID to be unique across the table. And then we'll specify that this user ID field is a foreign key, right? By passing in the field name there. And then the keyword reference is the name of the table, which is user, and then the name of the field, which is ID within the user's table, which is up here. Oops, up here. All right, so now if I do dot tables, we can see that we have two tables, the profile table and the user table. Does everyone follow so far? Cool. And right, so now let's start inserting values into each of these tables. I'll first start with the user table. I'll insert into the user table, name, the field, right? The field we want to enter into, values, and then Shungo. I'll enter another user into the table, Jessica. And now if we select all from users, we can see that we have two entries, myself and Jessica with our respective IDs. So hopefully that's straightforward so far. And now let's actually start inserting data into our profile table. So we'll do insert into profile and the fields we want to enter into, which will be net ID and user ID. Net ID, oops, I just called it net ID, and user underscore ID values. Well, I guess this isn't really a test of your backend knowledge, but it doesn't even remember my net ID. No, that's fine. Okay, SN685. All right, what would be the user ID for this entry right here? 1, correct. Thank you for the singular finger that went up. Okay, insert into profile. Net ID, user ID, values. Anyone Jessica's? No? All right, that's fine. And 2, right? So now we have entries in our user table and in our profile table. And I guess I could have like swapped up the IDs of the profile table and the user ID it's associated to, but that doesn't really matter. The point is, this entry right here in the profile table, right, has an ID of SN685, and the user that it's associated to is a user with ID 1, right? This entry right here, the ID of JZS27, is associated to the user with user ID 2. Yeah. So now if like, let's say, I want to add like another person in our profile table, and that's Gonzalez net ID, that's our backend lead. Let's say I want to associate his net ID to like my user, right? My user profile. Well, we specified up here that the foreign key has to be unique, right? So this isn't, SQL isn't gonna let me do this, right? Stepping unique constraint. So that's not gonna happen. Again, the benefit of using a database as opposed to a Python dictionary, if this wasn't clear enough. Cool. So that's a one-to-one. I noticed there was a question earlier that was very good about why we use one-to-one relationships in the first place. Yeah, I don't know if that was like fully like understood. So just like re-explain. Let's say we want to be creating an app for like booking rooms, right? And let's say one of the information about this room booking is like when the room is booked from, when it's booked to, you know, like what time, how many people are going to attend, like all that kind of thing. Maybe like the number of attendees is like specific to that event, right? But like when it starts, when it ends, all that like detail can maybe be like wrapped into a table called like timestamp, for example. So usually you would use a one-to-one relationship for something that, you know, you wouldn't traditionally want to represent in like one variable in like Python, for example. You would want to represent as an object, right? So like, as opposed to like, you know, having the time start and time end, you would have like a time frame object, which would then be a different table, for example. So it's kind of like to like modular, make things modular and like separate things out. That way it's like understandable. But yeah, that was a great question from earlier that I wanted to make sure everyone understands. Cool. So that was one-to-one. Let's get into one-to-many. So, right, there's several types of one-to-many relationships. I think the one mentioned in lecture was post. So let's do that one. So I'm going to create a new table called post. It'll have an ID of integer primary key auto increment. And it looks like no one's copying anymore. Am I typing too fast? Sorry. The description will be a text not null. The user ID, right? The person who actually posted this post will also be an integer. But this time, I mean, it has to be not null because we want to know like who actually posted this, made this post, right? But this time we don't have the unique keyword because, right, a post doesn't have to be like unique to a user. Like a singular user can make multiple posts. So that's why this field isn't unique. And likewise, we'll mention specify that this user ID field is a foreign key. Foreign key user ID, references, user ID. And the syntax here is just references and then the table name and then the field within the table that we're trying to reference. Cool. So now if we do dot tables, we have a post table, a profile table, and a user table. Also, hopefully this is like visible in the back. Please let me know in the future if it's not. I can always change that very easily. Okay, so let's start inserting data into our post table. Description, user ID, values. All right, what is something that Jessica would say? I don't know. I love Max flatbreads.
They're so good.
That is something she would say. Okay, she has the user ID of 2, so let's do that. And then, well, I guess I can carry on the example from last semester. My co-instructor gave like demo 3 last year, and she wrote, well, in place of Jessica was her name, but Jessica is such a better course instructor than me. So that can be my post, user ID 1.
Aw, thanks, Shingo.
Insert into insert into user ID values. Let's make another post for myself. I don't know. I love baseball. So notice here, like I made 2 posts for myself, right? Both with the user ID 1, but because the unique constraint wasn't there, I'm able to make those 2 posts. Cool. So it's actually very cool. Select all from post, right? Oops. Post. And you can see here that we have 3 posts, right? 1 being from Jessica and 2 being from me. And kind of like combining the concepts we learned from last week. If we do like select all from post where user ID equals 1, for example, we can see the post that I specifically made, right? So this is why one-to-many relationships are very useful. And you can see how like, you know, like I think homework 1 was like posts and comments, right? That would be a one-to-many relationship. Yeah, sorry for not teaching you that before homework 1, I guess. Okay, does that make sense so far? One-to-one, one-to-many. All right, let's get to many-to-many. So this is the one that's going to start tripping people up, I think. It's the one that tripped me up, at least. So let's create a table called feed. Now this will be the join table that, or sorry. We'll first create a table called hashtag with the ID integer primary key auto increment. And and then the name of the hashtag. Okay. So this is like on Instagram, right? Like a singular post can have multiple hashtags, and the same hashtag can be used by multiple posts, right? So this would be a many-to-many relationship. So using this hashtag table that we just created, we can now create a join table or an association table that kind of like combines the two together. So we'll call that table feed, right? ID as well as usual, integer primary key auto increment. Post ID integer not null. Hashtag ID integer not null, right? So this is relating the two tables. We have foreign key, post ID references, post ID, and foreign key hashtag ID, hashtag ID. Cool. So we have a post table, right, with IDs for each post and a hashtag table with IDs for each hashtag. Okay. So now we can start making hashtags. So let's start with that, right? Let's start by making hashtags and then later explore how we can actually relate the two hashtags and posts. So we'll insert into hashtag name, and let's call this one like food, hashtag food. And then insert into hashtag name, hashtag cool or something. Sorry, my hashtags are very lame. Not a grammar. Select star from hashtag. All right, so we have two hashtags, food and cool. Okay. So let's like first display both posts and hashtags, right? So we have these three posts and these two hashtags, right? And we can assign multiple hashtags to multiple posts and vice versa. So the way we're going to do that is by inserting into this feed table, right? This feed table has 3 fields. One ID is just to uniquely identify each row in the table. This one isn't super important. The other two that are very important are the post ID and the hashtag ID, right? So it's kind of like pairs of relationships. So let's insert into feed, right? And the 2 fields we'll be entering into are the post ID and the hashtag ID. Okay. So, right. So what post would like be appropriate for the food hashtag? Probably the first one, right? Maybe the third one, but if we're adding the food hashtag to the first post, what would the 2 values be here? Any ideas? Right, the food hashtag has ID 1. Cool has 2. Yeah, 1 and 1, correct. Thank you. Perfect. Okay. All right, let's try another one. Post ID, hashtag ID. Let's add the cool one to the second, or actually, let's add the cool one to the third post. All right, that would just be 2 and 3. And you can add the cool one to like the second one too. Maybe the first one as well. Okay. So now if we do select all from feed. Yeah. Oh, you're right. Sorry. Oops. Let's not delete. No, I can delete. Okay. What was it? 3 and 2? Right? Okay. Thank you. 3 and 2 and 1 and 2, right? Yeah. Okay. Thank you. All right. So this looks very cryptic. I have no idea what's going on. So how are we gonna figure this out? So this is now we start getting into the intricacies of SQL that's not gonna be like within the scope of the class. But as you can tell, database design is pretty cool. And if you learn SQL, eventually you can do cool stuff like this. And this is nothing like what's going to be tested for this course. So you don't need to like memorize this at all, but just some cool things I want to show off, I guess. So select post.description, hashtag.name from feed inner join post on feed.post ID equals post dot hashtag on tag ID equals hashtag dot ID. Okay, that was a lot of work for nothing. Oh, I am. Okay, I didn't need that closing bracket, I think. Post feed inner join post on inner join hashtag. Yeah. Okay, so that's much better, right? We can tell what post or like what the description of the post is and like what the name of the hashtag is. And we can even do cooler things like select, oh god, this is gonna be even longer. User.name post.description hashtag.name from feed inner join posts inner join user post dot user ID equals user dot ID on feed dot post ID equals post dot ID hashtag dot ID. So now we can even tell the user of like the poster, right? So again, SQL intricacies, but clearly the relationship is defined, right? Otherwise, we won't be able to do something like this. Oh, was there a question or? Okay, yeah. So yeah, that's basically it for the SQL portion. I hope you found that entertaining, me messing up at the end as well. But yeah, I think that's basically it that we can cover with today's time, but hopefully that was enjoyable. One-to-one, one-to-many, and many-to-many. Any questions before we move on to Kahoot? Yes.
Where'd you learn how to do all that?
This iPad. No, I'm kidding. No. There's like lessons you can take on SQL. There's also like a database course like at Cornell, CS 4320, that you could take after this course, I guess, if you're interested. But yeah, I mean, it's not like it's just a bunch of like SQL commands kind of like compounded into one big thing. So yeah, you'll be able to understand if you look up what each of these keywords mean. Also, one thing I want to mention before we go into the Kahoot is that SQL can be typed in lowercase, but please don't do this. If you do this, you'll get style points off for the programming assignments because SQL, like, it's hard to tell, right, from this, like what the SQL keywords are, which is why we've been intentionally writing them in uppercase. But yeah, so like if you are curious after lecture, just look up everything I like typed in uppercase and you'll probably be able to understand them. Any questions? Cool. Okay.